Hi. So in this video, or in the next set of videos, what we're going to do is take our character controller that we currently have, and we want to break that character out, controller class out. Right now it's all one big class. We want to break it out so that we using different states to actually run our class. So we're going to be using the state machine pattern. And that will set us up to, after that, going and adding in our character mesh and the animations. Before we can quite get to refactoring our code, we'll do that in the next video. We just need to, and again, if you guys read the chapter, you would have seen that the code they write here has these virtual functions here. It says virtual void handle input, virtual void update, where void handle input and void update, this is the return type and the name. And they add this virtual to it. So this is the idea of virtual functions. All virtual functions is a template of a function. We call this part, this void handle input along with the parameters, we call that the signature of the function. This kind of, this is unique to this function. There's no other function with this name, these specific inputs, and this return type. So that's the function signature. All a virtual function is it just tells us that if another class derives from this class, it needs to implement these functions. Otherwise, it's not complete. And you'll see, in Unity, it's going to yell at us when we do that. So in this public, or in this class heroine state that, they've written in the book, there's two virtual functions, handle input and update. And later, you can see here, when they make a ducking state that it derives from heroine state, they've implemented this handle input, and they've implemented the update to actually have code in it. We're going to do that with our states. So our state's going to be a bunch of virtual functions, and we're going to implement these states as different states, kind of exactly as they've done here. And in C#, we don't really use the word virtual. Instead, we're going to make something called an interface. An interface is the same idea as these virtual functions. The syntax is just different. We don't use the word virtual. We use the word interface instead of class. So let's just take a look at it. So the example that I'm going to construct, and we'll see this in Unity, is imagine we had a bunch of vending machines. So we had a few vending machines. And I'm not going to draw these vending machines out, but imagine we had a few vending machines. And each vending machine is, they're going to have a list of stuff that they vend, but all the vending machines, all three of them, are going to be, they're going to share common functionality. They're going to have some differences. So what we can do is we can make an interface for anything that's vendable. And then we can have the vending machines implement those interfaces. So, our vending machine could be, a snack vending machine. They could be a drink vending machine. They could really, be any kind of vending machine. They could be one of those vending machines you see at the airports that dispense headphones. It doesn't matter. They all have some basic functionality. And if they implement the iVendable interface, they can implement these functions. So we can make an interface, and again, I called it iVendable. This is just convention in, I'm pretty sure most languages, we start with an I to show that it's an interface, right? When you read the capital I in the beginning, it's an interface of type vendable, so we call it iVendable. And this interface is going to have a few functions in it, right? So whatever goes with vending machines, I'm just going to add a few. So let's have a void show products. This is going to show all the products that's in the vending machine, so it takes no parameters. It's going to have a void accept money. This is actually going to take a float of type amount. So, it's just going to take the money, maybe add it to its total. And then finally, a string return type for dispense product. Which will take a product ID and ID. And it would just return whichever product name, so you can display it on your screen or whatever. So this iVendable interface can be implemented by these three vending machines, or really by anything that can vend things, anything that in your mind is can vend things, they can implement this interface, and they can gain its functionality. So a good way of thinking about this interface is it's like a contract. If my vending machine says it implements from iVendable, that means it's also saying that it's going to have access to these three functions. And that, as a programmer, lets us know that if I want to talk to anything that I know implements the iVendable interface, I can say with certainty that I can use any of these functions and it will work. So it's a contract between the interface and the class that implements it. And then just one small note in terms of interfaces, unlike normal inheritance, when we make a Unity class, we inherit from mono behavior, you can actually implement as many interfaces as you want. One class can implement as many interfaces, as you want. As long as we adhere to that contract and we implement every single function inside that interface, we can have as many interfaces as we want. All right, so let's just go into Unity and take a look at this. I'm going to use the exact same example that I used in Paint. And I'm going to make a snack vending machine. So I'm just going to call it Snack Machine. And we don't quite need any of this stuff. And before I actually, work on Snack Machine, let's make that interface. So just like we make a class, I'm going to make a public. Instead of using the keyword class, I'm going to use the keyword interface. And it's going to be iVendable. And, just like we saw in the example from the book, we just want to write this function's signatures. We don't need to use the word virtual in C#. You can, but we don't need to. So we'll just write void show products. We're going to have void accept money, which is going to take a float amount. And then finally, a string, what did I call it? Dispense product, which is going to take an int ID. And so finally, we have our interface, right? It has three functions. Instead of deriving from mono behavior, I can change this to derive from iVendable. Or in this case, we don't say derive, we say implement. This is implementing the iVendable interface. You can see this iVendable is turning red. If I hover over it, VS Code is nice enough to tell me the reasons why. And it's because it does not implement these functions yet. It says does not implement show products, does not implement accept money, does not implement accept or dispense product. We actually need to implement those functions. So I would need to make these functions, so show products, which, is just going to print a string that has the products. I still need to implement the accept money function. And it has to have the exact same signature. Oops, I forgot to put void. Oops. And maybe the accept money, we just have a total money kind of variable. And all accept money does is it adds to the total money. And you can see once I've implemented these two and I hover over this, I only have one error left, right? It says I have not implemented dispense product. So let me do that. That's actually a string, a public string, show dispense product. It takes an ID. And, this would be a great place to do a switch case where you could switch based on the ID. So if it was 1, we could debug dot chips. Then if we had 2, oh, I forgot to write case over here. If we had case 2, maybe it was chocolates. and so on and so forth. Depending on the product ID, we're going to have a different case. Actually, this returns a string, so instead of just printing it, I'm going to say return chips dispense. And really, I'm not going to sit and write out the rest of this, but you get the point. The main idea here is the idea of an interface, where we have a interface that we've created here. It has a bunch of functions, and when we implement that interface, it's important that we implement each of these functions. We just put the signatures in the interface, and we implement it with anything that implements the interface itself. So the next video, we're going to see that, where we first break out our character controller, and we're going to make an interface for states. And then we're going to implement those states into our character as different states. Thank you for watching.